Welcome to this video on distributions of the sample mean. More examples. Let's begin. After watching this video, you will be able to calculate the mean and standard deviation of a sampling distribution given the population mean, standard deviation, and sample size, and answer questions regarding the probability of an event by constructing a sampling distribution and using RGuru. Please watch my first video entitled Distributions of the Sample Mean before watching this video. I'm calling this example 6 because example 1 through 5 were in the first video. Suppose it is known that the mean weight of the dog population in Baltimore City is 50 pounds with a standard deviation of 9 pounds. It is not known whether the weights of these dogs are normally distributed. Barks Animal Shelter in Baltimore City, Maryland takes in stray cats and dogs as well as other animals. One day, Barks had 81 dogs in the shelter. Treat the dogs at Barks as a simple random sample of all the dogs in Baltimore City and find the probability that the sample mean weight of all the dogs at Barks was less than 48.2 pounds, greater than 51.32 pounds, or between 49.5 and 51 pounds. So how do we start? How do we begin? In fact, what kind of problem is this? So just pause this video for a second, think about how you would proceed, and then unpause it to see if your assumptions or your guesses were correct. So if we kind of distill out the information that we have, basically this is saying we have a simple random sample of size 81 taken from a population whose mean is known to be 50 pounds and whose standard deviation is known to be 9 pounds. So before we go any further, what is the shape of the sampling distribution? Or maybe a better question is, how do I know I have a sampling distribution? How do I know I don't just have a regular old normal distribution? Well, I know I have a sampling distribution because I have a sample size that's larger than 1. I'm given n. So that tells me that I have a sampling distribution. So let's pull up this picture. Remember, this is kind of a visualization of the central limit theorem. So my question to you is, can we assume that the sampling distribution is normally distributed? Well, the only way I can do that is either if my sample size is bigger than 30, or if I know the population is normally distributed. And if you go back a few seconds, right, we know that we don't know whether the population is normally distributed or not, but we have our sample size of 81. So regardless of how the population, the mean weights of dogs, regardless of how that population is distributed, it doesn't matter because we have a sample size that's large enough to treat the sampling distribution as approximately normally distributed. So now we can proceed and do a sampling distribution of the mean. So the mean, we need to find the sample mean and the sample standard deviation. So we know that the sample mean and the population mean are the same. So we can treat the sample mean as the population mean. But the sample standard deviation, remember, we have to scale it. We have to divide the population standard deviation by the square root of n. So let's go ahead and do that. So we have the population standard deviation is 9. The sample size is 81. Well, the square root of 81 is 9, and 9 divided by 9 is 1. That's really nice. It's almost like I designed it that way. I did. I wanted a nice even number, a nice whole number for our standard deviation. So, in conclusion, we are going to treat the mean of the sampling distribution is 50 pounds, right? Because remember, we're talking about the weights of dogs, and the standard deviation is 1 because, again, we have to divide by the square root of n because we're working with a sampling distribution. So what do we know? Now we have this sampling distribution, so we're going to have this distribution that looks like this. Notice the 50, the population mean, and the sample mean are the same, okay? But what is different is that our standard deviation isn't 9 anymore, it's just 1, because remember we had to scale it by dividing by the square root of n. So now we can start to answer those questions that we had a few slides ago. So the first question is, what is the probability that all 81 dogs, if we added up all of their weights, right, and we found the average of all their weights, that it would be less than 48.2 pounds. Then, same thing. Took those 81 dogs, found the average. What's the probability that the average weight of those 81 dogs would be greater than or equal to 51.32 pounds? And then what's the probability that the average weight is between 49.5 and 51? So let's see if we can walk through all 3 of these problems. So let's start with this one first. Okay, so how would I do this? Probably I'm going to need a normal calculator. So the screenshot here is from StatCrunch, which we don't use anymore, but you can generate this result just as easily in RGuru. So let's go over to RGuru and see how to do that. So in RGuru, we're going to go to probability simulation, and then we're going to click on probability, probability calculator, and continuous. Now, if you look at this drop-down menu, there are many options, but the default option is normal distribution, which is what we want anyways. So let's go ahead and let's make this a little bit bigger here. So our population mean, remember the average weight of the dogs is 50 pounds and the standard deviation is 1. Okay, so given that information, we want to know what is the probability that average weight of dogs was less than 48.2 pounds. And if I want to, I can just go ahead and click the eyeball and it gives me an answer here. But that doesn't make me happy. What makes me happy is actually looking at the graph. So let's look at that. Okay, and I'll zoom out a little bit here. Okay, and there we go. I have a visualization. I like this because it shows me exactly which side I shaded in case I clicked the wrong button or selected the wrong menu from the or item from the drop-down menu. Okay, so this shows me the probability of the average weight of those 81 dogs being less than 48.2 pounds is about, I guess, a little bit over 3%, looks like. So based on that result, we would say is about 0.0359 or 3.59%. So let's keep going. What is the probability that the average of those 81 dogs' weights is larger than 51.32 pounds? So again, you can use any software you want, but let us go ahead and go over to RGuru and try to do this problem. So I'm going to click on Basics again, okay, and get the screen up. So this time I want to select above. Notice when I do that, the number goes away. And so then I typed in 51.32, and again I hit this button right here. Okay, so the number that I'm interested in is right here, 0.09342. Okay, and again if I scroll down, this is a visualization of the normal distribution. So we would say that the probability is about 0.0934 or 9.34%. So let's do the last one. This is a between one, right? So we want to know what is the probability that the average weight of those 81 dogs is between 49.5 and 51 pounds. So here is, again, a visualization of what that would look like, again, using a different software from RGuru, but still giving you the same answer. So let's go over to RGuru and see if we can recreate this result. Okay, so we want 49.5 to 51, but this time we don't want below or above, we want between. So we want it to be between 49.5 and 51 pounds, okay? And then I hit this little eyeball here, okay? And hopefully you can see zooming out. It's asymmetrical, but that's okay. So this graph is showing us exactly what we want. The probability that the weight, the average weight of those 81 dogs falls between these two numbers, right, is around 50%. So to sum up, the probability is about 0.5328 or about 53.28%. So let's do another example. So let's suppose in a different city, it is known that the mean weight of the dog population there is 52 pounds with a standard deviation of 10 pounds. Furthermore, unlike in Baltimore City, it's known in this city that the weights of these dogs is normally distributed. On one day, the local animal shelter in the city has 12 dogs in it. Treat the dogs in the animal shelter as a simple random sample of all the dogs in the city, and find the probability that the sample mean weight of all the dogs at the shelter is less than 50 pounds or more than 53 pounds. Okay. So let's think about what information we're being given. So essentially, we have a simple random sample of size n equals 12 pulled from a population mean with a average weight, right, of 52 pounds and a standard deviation of 10 pounds. So what has to be true regarding the distribution of the population in order to use the normal model to compute the probabilities of the sample mean? In other words, right, here's our central limit theorem picture, right? What is our sample size? Well, n is equal to 12. So can we use the central limit theorem? In other words, can we assume that the sampling distribution is normally distributed even if the population isn't? we cannot because our sample size is not large enough. So we have to know that the population is normally distributed. But lucky for us, the problem says that it is. If we look here, it says, furthermore, the weights of these dogs is known to be normally distributed. So we are told that this population is normally distributed. So we can treat the sampling distribution as normally distributed as well, even though n is equal to 12, meaning that n is less than 30. So again, we can assume that the sampling distribution is normally distributed because the population is normally distributed. All right, so let's keep going. So now we want to find the mean and the standard deviation of the sampling distribution. Well, the mean of the sampling distribution is the same as the mean of the population, so that's going to still be 52 pounds. Okay, but with a sampling distribution, of course, we have to divide by divide by the square root of n. So we have 10 divided by the square root of 12. It's not a nice even number like the last problem. It's about 2.8868. So we have a mean of 52 pounds and a standard deviation of 2.8868 pounds. So now let's go ahead and take all of those values and put them into our guru to see if we can find the area under the curve. So I've already generated here a picture for you. Again, this was not generated using ArgGuru. I just kept it in here because I think it's a little bit nicer to look at in a PowerPoint than the pictures that ArgGuru generates. So let's see if we can recreate this for ourselves in ArgGuru. Okay, so again, I'm going to go back to my menu. I'll zoom in a little bit so you can see. So we said that now this new city, the average weight of the dogs is 52 pounds. Now, you might be tempted to put in 10 pounds for your standard deviation. But how come we can't do that? Well, we can't do that, remember, because we took that 10, remember, and we divided it by the square root of 12. So we said instead that our standard deviation is approximately 2.8868. So that's one very common mistake with these problems, is to put the population standard deviation in here instead of using the standard deviation of the sample mean. All right. So we have our mean and our standard deviation. So now, right, we can calculate one of those probabilities. So the first of the two probabilities asks us what is the probability that the average weight of those 12 dogs is less than 50 pounds. So I need to select below, and then I need to type in 50 pounds here. So let's go ahead and hit this and see what happens. So the probability is popping up right here as 0.2442. And again, I always like to look at my picture and make sure that it is showing me or shading the area that I meant to shade. So in conclusion, the probability that the average weight of those 12 dogs in the shelter is less than or equal to 50 pounds is 0.2442, or about 24.42%. Okay, and let's do the same thing. This time, let's find out what is the probability that the average weight of those 12 dogs is more than 53 pounds. Okay, so we're going to use all the same information, right? We're the same mean, the same standard deviation. We're just changing the sample mean. So again, I go back to my menu. So this time I'm going to select above from the drop-down menu, and then I'm going to type in 53. And when I look at the result, here's my probability right here, 0.3645. But again, it always makes me feel better to come down here and look at this graph and reassure myself that I did shade the correct portion of the normal curve. So in conclusion, the probability that the average weight of those 12 dogs is more than 53 pounds is about 0.3645, or about 36.45%. So we're going to go from talking about cute little dogs and puppies to talking about snakes. Yuck. I'm sorry if you like snakes. I'm so happy for you. I'm not personally a fan of snakes, and I'm most assuredly not a fan of the type of snake in this problem, which is a reticulated python. So it says herpetologists, which is a fancy name for snake scientists. They found that the length of a certain species of reticulated python are normally distributed, with an average length of 20.5 feet and a standard deviation of 2.3 feet. One herpetologist fears that pollution might be affecting the natural growth of pythons. Not really one of my fears. Snakes are my fear. The fact that snakes are becoming less populous or not growing as big, not my problem. So back to this problem. It says, what is the probability that the length of a randomly selected python is 19.5 feet or less? So let's pause here, because up until now, we've been working with sampling distributions, right? So we've had a population mean, a population standard deviation, and we've been given n as sample size. Well, what is the sample size in this first bullet point? Take a minute to think about it, pause this video, jot down your answer, and then unpause it and see if you were correct. Well, there is an n, but it's kind of hidden. It says a randomly selected python. So n is really just 1. So in this case, we are going to use the population mean and the population standard deviation. But then the question goes on to ask, what is the probability that the average length of a random sample of 30 adult pythons is 19.5 feet or less? So just take a minute and observe the difference between these two questions. Because on a test, for example, right, this might be the difference of you getting it right or getting it wrong. Because here, right, n is 1, so you don't have to change the population standard deviation, right? You don't have to scale it by the square root of n. Over here, right, now we're talking about a sampling distribution because we're saying what is the probability that the average of 30 snakes is 19.5 feet or less. So they almost look like the same problem, right? But they're actually quite different. So let's keep going. Okay, so what is the probability that a randomly selected python is 19.5 feet or less? So this is actually kind of a blast from the past, right? This is just a simple question using our normal calculator. So you can see the result here, but let's go ahead and generate it as well in our Guru. So going to our Guru, the average length, the population mean was 20.5, and the population standard deviation was 2.3 feet. So if you don't believe me, you can always go back, just go back a few seconds to where it was on the screen. Okay. So then we want to select below, because it said less than 19.5 feet. Okay. And then let's go ahead and look at this answer. So you can see the probability here is about 33%. Okay, and again, if I scroll down, I can see that I did shade the correct area because I wanted, what is the probability that it's 19.5 feet or less? And again, that's the answer that we have here on our output and right here. So let's go to the second part of this question. So what is the probability that the average of 30 snakes, the average length is 19.5 feet or less? So now we are looking at a sampling distribution. And we know that because n is greater than 1 now. So the sample mean is the same as the population mean, still 20.5 feet. But we have to take the population standard deviation, which was 2.3, and divide by the square root of n, which in this case is the square root of 30. So that gives us a standard deviation of 0.4199 approximately. So now we can take that information and we can plug it into our Guru to get the area under the curve. So let's go ahead and do that. So I don't need to change my mean. All I need to do is change my standard deviation. And conveniently, I don't have to change this either, right? I just have to change my standard deviation. So let's look at the graph and see what happens. Notice my probability, right? It was much higher than this. Now it's less than 1%. It's very, 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 very small. Okay, and again, you can see that I'm shading to the left. So take a minute to think about why this probability is so low. It's less than 1%. It's 0.86% when I have an average of 30 snakes. Why was it so much higher with just a single snake? So remember, the probability that a single snake was 19.5 feet or less was 33%. That's a pretty big number. And then all of a sudden it dropped down to less than 1%. Okay. So the simple answer to that question of why is there such a huge change is because we're looking at the average length of 30 pythons. So an interesting thing that, and a limitation of the technology and the software that we have is that if you look at these graphs side by side, and again, these are taken from StatCrunch, not our Guru, but it doesn't matter because the same is true of our Guru. The shape of this curve is always the same. Right? And it looks like these curves are the same size, doesn't it? It looks like they're the exact same shape. And it's not till you stare at them for a little bit longer you realize, oh, actually, you know what? The scale on the x-axis, do you see that? The scale is much different, isn't it? That's interesting, right? This one goes from 13.6 to 27.4. This one is the same shape, but it goes from 19.5 to 21.5. It's much narrower band. Likewise, right, if you look at the vertical axis, this one only goes up to 0.15. I mean, the height is a little bit higher than that, right? But the whole thing is less than 0.2, whereas this height, right, goes all the way up to 0.8. So why am I putting out all this silliness? Why am I talking about this? Well, I'll tell you why. If I were to put those two curves on the same exact graph, which unfortunately is not something that statistical software often does, you would see two completely different shapes. So what is happening to the shape of our curve as our sample size changes? So the blue curve, notice right here, is this flat one where n equals 1, right? Now as n equals 30, right, this is narrowing in. It's getting much higher. It's getting much taller and much narrower. So why is that happening? Why is it doing that? Well, again, as I increase my sample size, right, the probability that my average is out here in the two tails, in either tail, that is very low or very high, it's going to get less and less and less and less. And all of my averages are going to get clumped and grouped around the population mean. So having watched this video, you should now be able to calculate the mean and standard deviation of a sampling distribution given the population mean, standard deviation, and sample size, answer questions regarding the probability of an event by constructing a sampling distribution and using our guru.